Hello, today we'll be looking at geometric sequences and series. Geometric sequences are a sequence in which each term is obtained by multiplying the previous one by a fixed quantity, which is written as R, which is the common ratio. The common ratio, or the formula of the common ratio, is given as un divided by un minus 1, where n is a random number in the sequence, denoting the term of the sequence. For example, in the sequence 2, 6, 18, 54, and 162, the common ratio is R, which is un divided by un minus 1. So we can take the second term divided by the first term. So u2 by u2 minus 1. So R will be 6 over 2. R will be 3 in this case. Now that you know how to find the formula or find the R of any geometric sequence, let us look at how to find the nth term, or un, of a geometric sequence. So the nth term is obtained from the first term by multiplying by n minus 1 common ratios. This leads to the formula being a times common ratio to the power of n minus 1. A here is the first term of the entire sequence. It should usually be given to you, and certain questions can be given, so you could have the nth term and their common ratio, and you need to find the first term, and vice versa, interchangeable. Next, we will look at some questions on geometric sequences and series. So we need to find the 10th term in the sequence. So the sequence given is 2, 6, 18, 54, and 162. Just the one we just looked at, which is a coincidence. The first term is 2. The common ratio can be obtained by dividing 6 by 2, which is 3. And the n is 10. So un or u10 is given as a times r10 minus 1. So u10 is given as 2 times the common ratio, which is 3 to the power of 9. u10 is hence equal to 39,366. Let's look at another question. Find the 11th term in the sequence 1, negative 1 over 2, 1 over 4, negative 1 over 8, 1 over 16, and so on. So a here is 1, n is 11, r is 1 over 2 divided by 1. That was a really long division, which is given by negative 1 over 2. That's very straightforward. So when you have the first term as 1, the second term is usually the common ratio, or it is the common ratio. Now let's find the 11th term. So the 11th term is 1 times negative 1 over 2 to the power of 10. So u11 is negative 1 over 2 to the power of 10, which is approximately 0.00097. You can give your answer in a fraction as well, but I like putting mine in decimals. Unless specified by your teacher, you can put it in anything pretty much. Now that you know how to solve some simple geometric sequence problems, let us look at a geometric series. And what is a geometric series? As mentioned in my last video about arithmetic sequences and series, a geometric series is essentially just the sum of all of the terms in a geometric sequence. So, for example, in the sequence 3, 6, 12, 24, and 48, the sum, or this is the sequence, but the series would just be 3 plus 6 plus 12 plus 24 plus 48, etc. So now, how do we deduce, or how do we derive the formula of the sum? We know that the sum of nth terms is a plus a times r plus a times r squared, and so on, right? Since this is just the formula of un is equal to a times rn minus 1. So as we go on, it increases. Now, let's add an a r to the power n here. Now if we multiply both sides by r, we get r times Sn is equal to ar plus ar squared plus ar cubed all the way till plus a rn. Now, if we subtract this equation from this equation, or sorry, vice versa. If we subtract number 2 from number 1, we get this Sn minus r times Sn is equal to a minus a r to the power n. Since all of these are common, they will get cancelled. Now we can take Sn common, so Sn will give 1 minus r, and here we can take a common, it will give us a 1 minus r to the power n. Hence the formula is derived as, let's cut this, the formula is derived as the sum of nth terms is a times 1 minus r to the power of n divided by 1 minus r. Now this formula can be rewritten as a r to the power n minus 1 divided by r minus 1. This is because it is usually used, like it's usually mentioned that whichever formula gives a positive value in the denominator is used. So that's why you can rewrite it depending on the value of your common ratio. So you usually use this one, or the top one, when your absolute value of r is less than 1, and usually use the bottom one when your absolute value of r is greater than 1. So you can get a positive value each time. Let's do a couple of questions. So find the sum of the following series. 2 plus 4 plus 8 plus 16 and so on till the 9th term. So we can use the formula S9 is equal to 2, which is the first term, and now the common ratio is 4 divided by 2, which is 2. So since r is greater than 1, we will use the alternative formula in which r comes before the 1 in the formula. So we'll have 2 to the power of 9 minus 1 divided by 2 minus 1. Now 2 minus 1 is just 1, so you can cancel this out. We'll get 2 times 512, which is 2 to the power 9, minus 1, and this is 1022. Let's look at another one, this time with a negative sign. Just add a bit more spice. 5 minus 15 plus 45 minus 135, etc. till the 7th term. So this can be written as 5 plus negative 15 plus 45 plus negative 135 and so on. So it's easy to visualize that this is a geometric sequence with a negative common ratio. So the common ratio in this case would be negative 15 divided by 5, which would be negative 3. Now that we know that, and our n is 7, so r is negative 3, n is 7, and the first term is 5, positive 5, so it's fine. We will use the sum formula, which is given as, since r is negative 3, it's less than 1, we will use the first one. So 5 times 1 minus negative 3 to the power of 7 divided by 1 minus minus 3. This will be given as 2,735 when calculated. So this is essentially just the summary of geometric sequences in series. So let me just go over the lesson really quickly. So the nth term of a geometric sequence is given as the first term, which is denoted by a, multiplied by r to the power of n minus 1. R can be calculated by u to the power of n, un, the nth term, divided by the term that precedes it. Then we come to the sum. So sum of nth terms is given as a 1 minus r to the power of n divided by 1 minus r. And this can be rewritten as a r to the power of n minus 1 multiplied by r minus 1. These two only matter when r is less than 1, and this is when r is greater than 1. This is for the positive answer. Hence, this concludes our lesson on geometric sequences in series. I hope you understood. As always, the comment section will be open for any questions and queries that I will answer in separate videos. Thank you, and good luck.